Hey, hi everybody. Welcome to this third IB webinar. Today, the focus will be on the aging process of the wine. So about the additives and process aids that you can use to increase the quality of your wine. Let's start with the presentation. So during the aging of the wine, which at the end of fermentation as a complex matrix, a subtle reaction occurs that can improve the taste and the flavor of the wine over time. The traditional aging technique is based on the storage of the wine in oak barrels. And there's differences between aging wine in barrels and aging wine in a bottle. And that because in a barrel, there is some oxygen transferred, and the wood can impart and can share with the wine some components, while the bottle is more an inert container. So what happens inside a barrel is that oxygen can diffuse into the barrel, and the oxygen react with the phenolic compounds of the wine and with phenolic compounds of the barrel that can also share and give some aromas to the wine. So to understand what's happening inside a barrel, we have to first try to understand what are the phenolic compounds. And to start, I want to share to understand why the phenolic compounds are so important. The first things to notice is that phenolic compounds are very important to define the quality of the wine. In this graph, we can see it's about a Pinot Noir, and we can see the G is gold, the S is silver, and the B is bronze, and high pigmented and high tannic wine. So are the one that receive more scores, so have a higher qualities. And also, it's very important to understand that viticulture technique are important to define the amount of phenolic compounds you can have in your wines, but that winemaker cannot rely only on terroir expression, but to achieve a consistency in style and quality, winemaker have to put some effort and wine and techniques regardless of the vintage conditions. So the phenolic compounds in the wine can be divided in flavonoid, which are present in the grapes, in which catechins are catechins that are present in the cedar, they're bitters, while the flavonols and the anthocyanins are present in the skin. One is more an antioxidant, and one is responsible for the color. And the non-flavonoid, which can be present in the grapes, but not only. They can come from the wood too. And this simple compound can be present in a monomeric form or can be present in a polymeric form. And this polymeric form is responsible for the structure, for the stringency and the bitterness that you can find in wines. Starting from analyzing the compounds, anthocyanin and the anthocyanin-derived polymeric pigment are responsible for the color of the wine. That is the first sign of quality. And anthocyanin in the wine at the pH of the wine that is around 3.2, 3.8, are present in their colorless form for the most. So they cannot, because for the pH of the wine. So the anthocyanin in the wine, and to express the color of the wine, the anthocyanin can be free, but cannot express it that much, or can react with other components to stabilize this color. And in a young wine, the color is stabilized by copigmentation. Copigmentations enhance the color of the wine and is a complex between an anthocyanin and a cofactor that is colorless, that could be other monomeric tannins, phenolic compounds. However, the copigmented anthocyanin is not the more stable form of color in wine. The most stable form is the polymeric pigment that is created between an anthocyanin and a polymeric tannins. And this binding is not happening by itself, but it's happening through an acetaldehyde bridge. And what happens is that in a barrel, the oxygen react with the ellagic tannins of the wood that get oxidized and produce peroxisome. This peroxisome react with ethanol, creating acetaldehyde. And once this acetaldehyde is formed, can then help binding these tannins and anthocyanins to create the more stable color and this polymeric pigment. So this is a schematization of the aging process and the reaction and the formation of polymeric pigment in the barrels, and the polymerization between the tannins and the color not only stabilize the color, but helps keep both compounds in your wine. In fact, aside from the reaction that involves the anthocyanins, tannins in your wine continuously go through this condensation and hydrolysis reaction. And this reaction helps the wine to gradually reduce the astringency. How? Because there's a change of structure in the wine because of this breaking of bonds and creation of bonds. So the change of structure in the tannins reduce the astringency, but also because of the aldehyde formation that we talked before, aldehyde help condense the tannins with each other, and when they reach a bigger molecular size, they can then precipitate out of your wine, again reducing the astringency and the bitterness of your wine. As we mentioned before, the phenolic compounds that are coming these times from the wood are also important because they share aromatic compounds in the wine, and these aromatic compounds depend on the type of oak, on the age, and on the reuse of the oak, and of the toastiness of the oak. But they can usually be referred as coconutty, vanilla, or more chocolate, and even like some tobacco flavors. Also, phenolic compounds are not the only compounds that impact the aging of the wines. Another compounds that are that are present in the wine and affect the aging process are polysaccharides. Polysaccharides in wine result from microorganisms they come from the cell wall of the yeast, or they can come from directly from the grapes. However, the monoproteins are the most abundant polysaccharides in the wine. So in the past, there was developed these techniques in the barrel where the aging of the wine was done on the lees of the yeast to ensure that the cell wall of the yeast was breaking down and release more monoprotein. This is the Surly method, while the Batonnage method was to mix this yeast lees to, again, fast the process of breaking down the cell and releasing the wine, the monoprotein. So this aging the wine over the lees what not only is not only used for white wines, but nowadays this technique has become more and more popular for red wines too, to increment the structure, the aromatic profile, and the use of monoproteins also show to help with color stability. And in fact, the polysaccharide have been related to modulate the astringency. And how they modulate the astringency is they modulate the astringency because they interact in this hydrolysis and condensation of tannin, modulating their interaction. They can reduce the sensation of hotness in very alcoholic wines, and they increase the viscosity and the body of the wines. These techniques I talk about, however, have their disadvantages in the winemaking nowadays. In fact, they're very time-consuming. The barrels are and the space and the turnover is very costly. You can lose a lot of volume because of evaporation, and there's always the risk of contamination by undesirable, by spoilage microorganisms. So IB has put a great effort into develop new product that can improve the aging of the wine. So the first thing is a product that add phenolic compounds to the wine, and this addition of phenolic compound can improve the mouthfeel and the wine aromas, can help precipitate the protein. They can inhibit some enzymes that are undesirable, and they can help stabilize the red wine color too. To understand like how can you use different products, you have to understand how they behave differently. In fact, like ellagic tannins and proanthocyanidinic tannins, they behave very differently, because one, the ellagic tannins help to capture the oxygen and help create acetaldehyde. Then the acetaldehyde react with the proanthocyanidinic tannins, creating the complex or stabilizing the color. So IAB create different line of ellagic tannin and proanthocyanidinic tannins to address this specific task. And the first differences between these two different product line is their chemical behavior. But the chemical behavior result in two different taste modification. In fact, like the ellagic tannins are more soft on the taste, and they promote the other polymerization of the proanthocyanidinic tannins that increase in size and precipitate, and so create a wine with a softer taste. And while the proanthocyanidinic tannins are the more structuring, so they create the backbone of the wine, and they behave like skin or seed tannins depending on the origin. They have ellagic tannin and proanthocyanidic tannins. They have two different work. They do two different work in the color stabilization, but you need both in the wine when you want to stabilize color, because the ellagic tannins is responsible for the first part of the reaction, while the proanthocyanidic tannins has to be activated to start the condensation reaction, the copigmentation reaction. And so all of these different features result in two different use, where like the ellagic tannins are used in structured wine to soft structure wine and to help fix the color, while the proanthocyanidic tannins are used to give structure to the wine, to give more strength and aging potential to a wine that after vinification was poor of this kind of tannins. But both of the tannins work simultaneously, and therefore understanding which one is the best for your particular case can help you tailor your action to the desired achievement. And as a summary, the condensed tannin, so the one that are coming from the grapes, binding with each other and protect from oxidation, and they're the mainly responsible for the stringency and the structure, while the use of ellagic tannins can impart more flavor from the oaks with like fruity notes, and they increase the structure but with lower astringency, and they help soften the astringency of the condensed tannin during aging. So IFB developed different proanthocyanidic tannins, which they all have the same scope, that is structure, stabilize color, and extend shelf life. However, they differ from the source. So the protein Malbec and the protein pepin are derived from the grape seeds, while the protein peel and the protein resin bridge are derived from grape skins, and the protein boys is derived from quebracho. Quebracho is a wood. However, it is rich in this polymeric condensed tannin, and I think they can help you starting from the quebracho, that is giving like more structure and is like more rough, to the seed tannins, to the skin tannins that instead are the more velvety and light on the palate. Also, IB developed a list of ellagic tannins, and the ellagic tannins differs on the ability to have an antioxidant action, so promote this protection from oxygen and production of acetaldehyde, but also differs in the kind of aromas that can give to your wine. Whereas the first ellagitan cene can give you the protection and from the oxygen. It helps the aging without giving too much woody notes. The ellagitan extreme instead like protect from the oxidation and reduce the structure, the harshness of the green tannins that you can have at the end of fermentation or at the end of extended maceration, giving to the wine also some spice expression, while the Tanniker and Tanny Blanc are very antioxidant, and the Tanniker is especially for giving this chocolate sensation, and is also very recommended to use with micro oxygenation. A particular mention, I think, has to be made with another couple of products that we develop that are Tannetyl and Tannetyl F. Tannetyl and Tannetyl F are bioengineered tannins, and are bioengineered because they are extracted in a way that the acetaldehyde bridge is already present on the tannin, and so you don't need oxygen and you don't need ethanol in order to create acetaldehyde. So these tannins are very useful when you want to stabilize the color and you don't want to over-oxidize, or you're worried to over-oxidize your wine. And also is very useful, for example, during cold soak, because during cold soak you don't have ethanol and you don't have acetaldehyde that is formed during fermentation, and therefore you can stabilize the color immediately. Alongside these tannin powdery tannins, IB developed also liquid tannins, and the ability of the liquid tannin is that because of the method of extraction, you can condense the aromas that comes from the wood, and therefore they add structure to the wine and aging potential to the wine. However, liquid tannins are very good to increase the aromatics of the wood in your wine, and depending on the toastiness level and depending of the oak that we use to produce, we have different product that can help you aim or achieve different result aromatically. So also, at the addition to the phenolic compounds, addition of polysaccharide is also allowed in wine, and you add polysaccharide to seek a balance between the drinkability and the aging potential, to improve color and tartar stabilization, and also to improve the sensory properties such as mouthfeel and viscosity. And in wine, two types of polysaccharide are allowed, and the first one are derived from yeast, that are usually yeast monoprotein and yeast-derived products, and the other come from a plant that is the acacia, and is the product from the acacia is gamma arabic. So the polysaccharide from the yeast are produced killing the yeast and separate the component of the yeast. When you separate the components of the yeast, you can have the extract that is soluble and is rich in amino acid, the mannoprotein that are the exteriors of the cell wall, and the yeast hulls that are insoluble and they have different characteristics. So each of the three components have different physiochemical characteristics, and they have three different effects on wine. The mannoprotein are used to improve the tartaric, are very soluble, and they help the colloidal stability of the wine and also increase the viscosity. The yeast extract is very rich in amino acid, and the amino acid can increase the umami, so the flavor perception, but can they also increase the sweetness perception in your wine, while the yeast stalls are a very absorbent component, so they can help you like cleaning and fining your wine. And therefore, different blend at different concentration of these compounds can result in different products to better aim, to better help you achieve your aim in your wine. And in fact, different batonnage product can be aimed to different results, that could be the maintaining the redox potential and protects from oxygen, or increase the body and decrease the astringency, and also help you preserve the color. IB range of batonnage product is wide. Here I selected some, and you can see that they have different composition, specifically targeted to achieve different result in the wine. In fact, their different composition result in different application in your wine, where the élevage glue is the one reaching to the tyon, and so is the one that protects your wine more from oxidation, and therefore protect the aromas. Very recommended for like aromatic white varieties. While, for example, the batonnage body is the one with more of the yeast extract, so more amino acid concentration that can help you increase the umami of your wine, so the perception of aromas. And there's a couple of others blend that can that different in composition, and therefore different in the application that you can use in your wine. Also, IB has a product that is a pure monoprotein. It's called Superman, and is the one that has the high colloidal power. So it's the one targeted to improve tartaric stabilization, but also it has a specific tactile sensation. And in fact, aside as improving the tartaric stabilization, here you can see in the graph how the addition of Superman make the wine stable, but also it can help you like smoothing the roughness that can derive from excessive tannins and excessive acidity in your wine. Instead, the other polysaccharides that come from the plants are gamma-arabic. And the polysaccharides, the gamma-arabic is more similar to the polysaccharide that comes from the grapes. So it's an arabinogalactan, rich in protein. And the two plants where gamma-arabic is extract is Acacia senegal and Acacia seyal. And they have the same common structure. However, they differ in the degree of the branching. As you can see, here is the common structure, the black one, the black part, while the debranching is the white part. So they differ in the degree of the branching and the sugar concentration that they have in their branch, and they differ in the molecular weight. So they have different physiochemical and structural, and therefore it results in different abilities in the wine. In fact, the Acacia seyal is more helpful for tartrate protection, and it has a less effect on filtration, while the Acacia senegal is more useful for color protection, and it add to the wine more sweetness, more mouthfeel. So here is a study with our Arabinol Super Rouge that is 100% Acacia Senegal, and the Arabinol Super Rouge was used. This one was the control wine, and this was the Arabinol Super Rouge. And the Arabinol Super Rouge, 100% Acacia Senegal, was the best gum Arabic to protect color. And in fact, after 14 days of aging, there was almost no color loss in the wine. Also, this gum, as I said before, is the one that gives the more sweetening and softening power in the wine. Instead, Arabinol 30 is our 100% solution of Gamma Acacia Seyal, and Arabinol 40, as you can see here, compare to we tested in Chianti compared to the a control wine that was tartrate unstable. The addition of Arabinol 30 make the wine stable. Also, Arabinol 30 is the one that has the less impact on filterability. As you can see here, the control wine has this as a filterability index of 3, and the addition of Arabinol 30 just increase the filterability index by 1, while the other gum, that is the one more for color, it impact the more about the filtration. I also want to mention that the Arabinol comes also in the certified organic form. Last and not least, I want to talk about microbial protection, because when you put your wine in your barrel and you don't want to be spoiled by bacteria or spoilage yeast, that could be Brettanomyces or Saccharomyces bailey, Zygosaccharomyces bailey, and IB developed a new product that is called Chitocell, and is based on chitosan. Chitosan is a molecule that comes from a fungi, and this molecule, because it's positively charged in wine, react with the membrane of this spoilage microorganism and cause the death. And how you can see here was a contaminated wine before the addition of chitosan, and here was after the addition of chitosan. So chitosan help you reducing the microbial load, the spoilage microbial load of your wine, and so can help you reducing also the SO2 usage, improving the quality of your wine. And because SO2 can bleach your color, it also improve the color stability of your wine. And the usage depends on the contamination of the wine, and when you're using it. You can use it at the beginning of the fermentation because it doesn't have any impact on Saccharomyces growth, or you can use it during aging to stop unwanted or Brettanomyces. So here is my presentation. If you have any questions, you can write in the chat. I prepare already some questions. You can find it at the bottom of the screen in the pool section, and I'm gonna go through there. And if you have any question, you can write it in the chat, and Vince will help me answer to them. So first question was here we are. First question was, what phenolic compound is responsible for age wine color? And you answer copigmented anthocyanin. However, the right question is polymeric anthocyanin. So free anthocyanin and copigmentic anthocyanin are responsible for young wine color. However, for aged wine color, is the polymeric anthocyanin that is responsible because it's the more stable form of the color. Second question is which condensed tannin is the best for polymeric pigment formation? And you answer seed tannins and skin tannins. So in this case, I'm showing you a result of one of the latest studies using both grape seed tannin and grape skin tannins to stabilize color. And their result shows that grape skin tannins are better to stabilize color because they are less prone to this polymerization. Because they are less prone to this polymerization, skin tannins are better to stay in solution with the color. Third question was, or is, which part of the yeast cell has monoprotein? And the answer was like nucleus, yeast extract, cell membrane, or none of the above. And you answer cell membrane. However, it was a trick question. It's none of the above because the monoprotein are not in the cell membrane, but they are in the cell wall. In fact, if you see, the monoproteins can be attached directly to the beta-glucan, or they can be attached by other proteins, but they are not attached to the cell membrane. Next question is, which enzyme can help with monoprotein releasing during surly? And yes, you voted correctly, is the beta-glucanase. Beta-glucanase can help with speeding up the aging process of the surly aging process. In fact, if we see the picture before, because the monoprotein are attached to the beta-glucan, if an enzyme can break down this beta-glucan, it results in an increased release of monoprotein. And AB has an enzyme called endozyme glucapec, which can help you, but it can improve the filterability of your wine when you have too much glucan from spoilage grapes, but they can also speed up the aging process on the lees. Let's see. The other question is, against which microorganism is chitocell active? And I was saying gram-positive, gram-negative, gram-positive, and gram-negative, and spoilage yeast, and all the above. And all the above is the right answers. In fact, compared to lysozyme, that is effective only against lactic acid, chitocell and in general chitosan product have been shown to have a broader spectrum of action, and they are effective against Brettanomyces, lactic acid, and also other spoilage yeast. The last question I prepare is, can gamma arabic also improve foamability of sparkling wine? And I want to show you this study. It has been published in the Journal of Food Chemistry. Journal of Food Chemistry. And gamma arabic has been shown to improve the foamability, so the high of the foam, but only the stability of the foam. The high is the black, and the foamability is the is the other one. And with the Acacia Seyal, so in this case the Rabinol 30, that has a better ability to increase the foamability of the wine. All right, so I see a question. I see a question in the chat. So the logic. How many years have you compared wines? So the question says, how many years have you compared wines made with it and the controls? 2 years or 10 years? So there's a lot of studies that has been done, not just by AB, and there's a lot of study with different years that shows that the addition of tannins can improve the quality of your wine. However, it's always depend on the starting wine. So you always have to understand what your wine is rich on or is missing, and then you can target your addition. So the result that you can get from these studies that consider always like short term or long term. However, the differences of the result is that you have to do the tannins addition based on the quality of your grapes or the composition of your grape. I think the best thing here is that recommended addition for each wine is not recommendable, but wines need targeted approach, and that's why the targeted approach and the IB representative can help you find the right solution for the wine, because there's not one right solution. In terms of ageability, the golden ratio that research has shown is that the ratio between condensed tannins and ellagic tannins should be 4:1. Right, let's see. So if there is, ask a question, let's see. So if there is any other question, you can add in the chat. I will just give you a couple of minutes if you want to add some question. All right, so Vince, I think there's no more questions. So I would like to thank everybody for coming and listening. And please, I focus in this presentation more on the science behind our product. So if you have more questions on the details of the IB products, please contact your sales representative, and we are happy to help to answer your questions. So thanks again, everybody, for coming. Thanks, Vince, for the support, and have a nice day. Bye.